Okay, in this short video, we're going to talk about scientific notation. This is going to continue on from what we talked about last time in terms of negative and zero exponents. So we're just going to evaluate some powers. Evaluate means write it just as a number. You can use your calculator. 10 squared is 10 by 10, which is 100. 10 cubed is 10 times 10, 100 times another 10, which will be 1,000. So each time the exponent increases by 1, I'm multiplying by another 10. So 10 to the power of 4, 10 times 10 times 10 times 10 is going to be 10,000. Now, we talked about this a little bit in the last video, but if you notice, there's a nice pattern when 10 is our base. Our number system works really well because it's a base 10 system. So when 10 is the base, the exponent 4 is telling me the number of zeros. If the exponent's 3, I'm going to have 3 zeros. If the exponent's 1, well, guess what? I'm only going to have 1 zero. If the exponent's 12, well, I think we can probably figure out that I'm going to have 12 zeros. What is a number with 12 zeros? I think that's going to be 1 trillion. A billion is 9 zeros, but a trillion has 12. I don't know why it repeats 10 to the 1, but it has 1 0. Now, again, in the last video we talked about negative exponents. So that would be 1 divided by 10. 1 divided by 10 to the 1. If I put that as a decimal, that's going to be 0.1. Same thing, 10 to the power of negative 3, you could do it in your calculator, but we know that's 1 over 1,000, 1 over 10 cubed, which is 0.001. So the negative exponent is going to tell me how many times I need to move the decimal place. So here we're in the first, our 1 is in the first column because it's negative 1. Here our 1 is in the third decimal place, the thousands column. So if it's a positive exponent, that tells me the number of zeros. The negative exponent, with base 10, it's going to tell me, well, what place value or what decimal place do I need to put the number 1 in? So the negative 3 tells me it's going to go in the third, tenths, hundredths, thousandths. We can work backwards too now that we know this. So if there are 2 zeros, that's going to be 10 squared. If there's 3 zeros, it would be 10 cubed. 6 zeros, 10 to the 6. 12 zeros, 10 to the 12. So it's really fast. We can convert these numbers into powers of 10. 1 0 would be 10 to the power of 1. Then same thing, if it's less than 1, we're going to have a negative exponent. Remember, negative exponents are taking the reciprocal, but here it's in the second decimal place, the hundredths place. It would be 10 to the negative 2. This one would be 10 to the negative 3. It's in the 1, 2, third place, and here it's in the 1, 2, 3, 4, 5. It's 10 to the negative 5. And you can always check this with your calculator. 10 to the negative 5 is 1 over 10 fifths, or you can just punch that in. So we're going to use this nice fact, or this nice pattern about powers of 10, to write very, very large or very, very small numbers in a simple, efficient way. So if I want to write the number of stars in the Milky Way, very big number, the weight of an atom, very, very small number, we want to figure out a quick, efficient way to write this. So if it shows up in an article or a textbook, we can read it quickly without having to count all the zeros or count all the decimal places. So we're going to express all these quantities as a number between 1 and 10. We call that the leading number. And then we're going to multiply it by a power of 10. So we'll try a few examples. But kind of a shorthand is, when you have a base of 10, every positive exponent, if you have a positive exponent, that number represents how many times we multiply by 10, or how many times we need to add another 0. And if it's a negative exponent, that represents really how many times we're dividing by 10, or how many times I'm moving the decimal place to the left. I don't know why I'm taking the time to write this all down on the video, but how many times we move the decimal to the left, which is the same thing as saying dividing by 10. So for example, all of these numbers are in scientific notation. And what that means is, you notice every single leading number is between 1 and 10. And then it's being multiplied by a power of 10. So 7 times 10 to the 6 is just another way to write 7 and then 6 zeros, or I've moved the decimal place 6 to the right. So the decimal place was here. I've moved it 6 spots to the right. 4.8 times 10 to the 4. Well, that means I'm multiplying it by 10 4 times. If that's my decimal, I'm going to move it to the right once. Then I've got to move to the right 3 more times, which is going to add my 3 zeros. So 4.8 times 10 to the 4 is a quicker, shorter, more efficient way than writing 48,000. So really big numbers, 2.7 times 10 to the 12. Maybe that's, the grain of sands on a beach. I don't know. Again, it's going to take me 1 decimal place to get past the 7. And then I still have 11 more times that I multiply by 10, so I'm going to add 11 zeros. This would be a really annoying number to write down in an article or to explain quickly. But if we just see this, well, we know, okay, that's 2.7 trillion because it's 10 to the 12. So that's a nice way to write it down. Same thing, if we have a negative exponent, I'm going the other way. So I'm starting with 3, and I'm moving the decimal place 2 to the left. So 1 puts it in front of the 3, then 1 more is going to create a 0. So another way to think about that is that my first leading number, my leading digit, is going to be in the second decimal place. 10 to the negative 5, same thing. 1, 2, 3, 4 zeros, and then my leading number 1, and then another 1, are going to be in the 5th decimal place. Another way to think about that is I started with 1.1, and I moved the decimal 1, 2, 3, 4, 5 spots to the left. So whatever works for you. Again, our leading numbers are always going to be between 1 and 10. 9.6 times 10 to the negative 1, I'm just going to move the decimal 1 place to the left, so it's going to become 0.936. I've just divided by 10 one time. So that's how we convert from scientific to standard. We can also go the other way. So let's say we're doing a science experiment, we got a big answer, a really small answer. We want to write this in a more compact, efficient way. So for example, 43,000, how many times do I need to move the decimal place to get my leading number between 1 and 10? So I've got to move it 1, 2, 3, 4 times, and then it would become 4.3. That's between 1 and 10. And because I moved it 4 times, it's going to be multiplied by 10 to the 4. If the number, again, is bigger than 10, it's going to be a positive exponent. Same thing here. How many times do I need to move the decimal place to get this number between 1 and 10? It would be 1 to the left, 2 to the left. So out of 7.82, right? That's between 1 and 10. Then because I moved the decimal place twice, I'm going to have 10 power of 2. Takes a little bit of counting on some of these bigger ones. I have to move. How many times do I move the decimal? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then I get the number between 1 and 10. So it's 1.25 times 10 to the 14. Sometimes people will only move the decimal past the 0. So I could, if you had written 125 times 10 to the 12, this is equivalent to the number. It is the same thing, but this isn't kind of how we write in scientific notation. So to make it easier to compare the quantities, to talk about the quantities, we always want our leading number to be between 1 and 10. If the number is smaller than 1, we're moving the decimal the other way, and then we're going to have a negative exponent. So it's going to be something times 10 to the negative. How many times do you need to move the decimal? Well, it's going to be 1, 2, 3, 4, 5. And now I've got 7.5. That's between 1 and 10 times 10 to the negative 5. You can always check your answer by just putting 7.5 times 10 to the negative 5 into your calculator. Same thing here. I've got to move the decimal twice because 4.52 is between 1 and 10. If I move it too many times, I'm going to have a number that's too big, 45. If I don't move it enough, I'll have a number that's too small, times 10 to the negative 2. A couple ways again, we can think about moving the decimal. I would have to move it 3 times to get the number 2. You can also think about the 2 is starting in the third place after the decimal, so it's going to be times 10 to the negative 3. So we're going to do this often if you're working in science. We often have numbers that are really, really small or really, really big, but to express them concisely, efficiently, to be able to compare them, to be able to do operations with them, we want them to be in scientific notation, which means we need to express them as a number between 1 and 10, and then multiplied by either a positive or a negative power of 10. That's all for now. You've got some practice problems to try, and let me know if you have any questions. Thanks for watching.